Okay, so this is my discussion session, and I choose two topics. So let's start with the first one. Yeah, okay. So as everybody knows, the course is called knowledge-based design, and knowledge-based design is design based on knowledge. It's pretty obvious. But when we talk about knowledge, nowadays we have so many ways to find knowledge. If you think about like internet and all the news we can see, we have a lot of information we can look about it. But the problem is that when you have so many information, you can find also wrong information. If you think about like the fake news, for example. So my question is, how is possible to distinguish between correct and wrong information? And when we talk about like machine learning, how can a machine distinguish between right and wrong information?
Well, for humans, for the first question, the obvious answer is to look at as many sources as possible,
Mm-hmm.
to not be biased and look at a lot of information in total. Then you could decide, and I guess it's up to the person to decide what to believe in the end, but it will help them determine which one is the correct information and which one is wrong. About the machines, that is a very difficult question. Not so sure.
Because like even humans, if you think about it, it's up to our common sense, but there are people who have more common sense than others. So for some people it's easier to find what is true, what is not. For others it's more difficult. I know it's difficult, that's why I asked. Because I want you to tell me.
I guess since in machine learning there's a database and it keeps collecting data, so when it finds something contradicting each other,
Mm-hmm.
I guess there could be some alert and some kind of algorithm to determine which one is true, which one is fake. For example, the number of websites that contain this information and compare like the numbers and then.
So you say like if information A is like, I don't know, 10 pages and B 100, you say 100 is correct.
I guess. It wouldn't be a real foolproof, but I guess it's one approach.
Okay.
Well, you should go for an authentic source of knowledge or news.
Oh, sorry.
An authentic source of knowledge or news. That is, in this way you can get the right information. By authentic source I mean.
You see the source, how is the source, and.
Yeah.
Okay, yeah. Can be one option, yeah.
Yeah.
So basically you see like you evaluate all the sources and you see, I don't know, Wikipedia is better than, I don't know, other websites, so you believe this one.
Yeah.
Yeah, okay. Some other ideas?
I think you need to be careful about when looking for the sources. You need always to, even the machine always, like, we talk about machine learning, but everything they have, every result they have, they should check it again or something. Because, like, even if the source is something famous, sometimes they just publish without any check, and so you don't know if it's correct or not. You should always, I think when machine learning, you should always like check if there's, or if at least like the scientific reasoning seems correct or not. If they're not, I don't know, if derivating something, we should not be derivating more basic stuff, but always checking how to.
Okay. Yeah, but even if you you need someone who checks this. If you think about, I don't know, like something mathematics, you need someone who check the calculation, but he or she can make a mistake.
Yeah,
You know, it's like a.
When you talk about machine learning, you have like this those basic rules.
Okay.
And they can, like, this is like common science.
You said like, okay, this is true. It's always true.
And every step maybe checking, like they're just using the true.
Okay.
Everything is true.
Okay. Okay. That's a good way.
Or a machine, let's say you're given a picture of a cat, and machine can say it's a cat or a dog, it's correct or not. But let's say a machine is given an article which can be wrong, then it will be really difficult to distinguish it is correct or not. But it will be eventually depending on how it was trained to determine.
It depends on the machine.
Yeah,
How
it's kind of like human. It's about how you determine and how you. It's about choice. What you believe or what you're not believing. So for a machine, it's the same problem, and how it has been trained so far. At the time they see the article or something like fake news. So depends on how it is trained.
Okay.
I guess like sorry.
No, yeah, of course.
I was like of the opinion that for the correct, like to distinguish between correct and wrong information, we have to like substantiate it with the facts. Like how many facts support a correct information, and like if it's a fake news, then no one would be discussing about it, right? Like if you want to substantiate news, if it's like a real news or a fake news, the one of the ways is to like check out how many people are talking about it, how many news articles are written on that particular topic, or how many people are like have the knowledge about it, or in the locality of that event, like where the event has occurred and the people around that area, how many people are talking about it.
Okay.
So using the data analytics analysis, we can like figure out if the piece of information is correct or not. But as for the machine learning, it's like pretty hard for machine learning concepts. But it depends on which machine learning concept we are focusing on. Like for the supervised learning, we as the writers of the algorithms are providing the machine learning algorithm with the correct set of news.
Okay.
For the supervised learning. But in case of unsupervised learning, the piece of information can be wrong as well.
So you see that the one who set the machine learning,
Yes.
like the programmer, has to set the right way to find the right
for
information.
The supervised learning case.
Okay.
But for the programmer to figure it out, if he has access to a big database or some algorithms through which he can like check out if a particular piece of news is correct or not, he can like do it using the social networks. Like if you have I guess Facebook was doing it in the same way. I'm not sure what. That if a piece of news article is coming from an area, like a report of an earthquake or a major gun scene, gunfight. So if the people around that area are talking about it, it's very easy to get who all are around that area with the GPS coordinates and all those things. So if the people are talking about it, then it has a higher possibility of being true.
Okay.
Rather than being false.
Okay. Okay.
So in that sense.
Okay. Yeah, it makes sense. Yeah. Perfect. Someone else, or I can go to other topic? Okay. So, topic 2. When we talk about, like in the first lectures, we talk about deduction, induction, and abduction. About the deduction, we say we have like the case and the rule, and we find the result. If you look at the dictionary, the deduction is the deriving of a conclusion by reasoning. So basically, you use the observation, so the cases you have, and using like your brain, you find the rule, and then you derive the result. But my question is like, how can you consider all the possible cases? I think also he talked about this in the last lecture. Because, for example, when there was the example about the cardinal, the birds, and we said the cardinal is a bird, all the birds flies, so cardinal flies. But if you think about also the penguin is a bird and he doesn't fly. So now this rule is no more valid. So before knowing the existence of the penguins, this was true. Now it's no more. So how can we consider all the cases, and if it's not possible, is the result like always wrong because we cannot find all the cases?
I guess it's not possible to consider all the cases. And to come up to the conclusion that the result is wrong, we need a test set first, which proves it's wrong.
Okay.
So it's like, if I just put it this way, it's not possible to consider all the cases, but to term a rule or a result wrong, we need a case for that. So until we encounter that case, it's fine, it's going correct. But if someone pops up with, oh, I have this example and it just proves your theory wrong, then like I'm screwed.
Okay. So basically, you cannot be 100% sure that it's true,
Yes.
but you have to be sure it's false to say it's false,
Yes, exactly.
more or less. Okay.
It's not necessarily like false. Maybe you have to be more precise in the way you say the rule. Like for the example of the penguin, you have to say maybe some other things. It's a bird and it has, I don't know what to say.
Okay.
So maybe the rule is not necessarily like wrong, but you need to work on it for sure.
Okay.
So you mean like precising the rule?
Yeah.
Okay.
Or have more like hypotheses on the rule or things like that.
Because what I thought was like, if you modify the rule, you're basically changing the rule. You're setting up on a new rule.
Or you just have a more detailed rule. And so maybe the cases you already have, if they just have this, they respect the more detailed rule, then that's okay. And you just don't have to do it all again.
Okay.
I think you need, to some extent, you need some luck. Because for example, Kepler, he didn't observe all the stars in the sky.
Yeah, of course.
And he picked some cases, and he mathematically did something right, and then he applied to all the stars. And then it turned out it is well applied to any cases, so it's kind of lucky.
Okay.
But mathematically, I think he was so sure, but I think that's the case for this gesture.
Okay. So being lucky is the answer. Okay.
As she said, you need to be careful when you choose cases.
Okay.
That's my.
I guess I have one more question to add to this. Is
Yeah, okay.
time and technology somewhere related to this?
I mean, of course.
Like as one of the third part of the question, the same question, this one.
Yeah.
It's like, do time and technology affect the rule or not? Like I was thinking just like during the ancient times, people tried to fly.
Yeah.
We fly, but like in a different manner, like they were trying. So does time and technology has any role to play in the rule of?
I mean, of course, because the more technology you have, the more knowledge you have, the more time means you will learn more things.
Yeah.
And when more things you know, better you can understand the rules. We have more cases, so you have more knowledge. So of course, this is all an evolution of.
I think with time rules may change. I think so.
Yeah.
Because we think that speed of light is the maximum speed. But recently in a nuclear experiment, the speed of electrons has exceeded the speed of light. So with time, things may change.
True. Okay. Someone else or? Okay. So, thank you for your attention.
I can.
Okay.
Just put prop.
Uh,
Because I want to make a copy of this.
okay. Sorry. I think I closed. Okay.
All right. Those two questions are related to each other, and they are tough. They are tough. For this, I have a towards say in Korean broadcasting news broadcasting, they are talking about fact check corner. It's popular now, fact check, because many politicians talking about different wording, right? So in broadcasting, news broadcasting corner, they has a new section for fact check. Or each day there is a new wording from the politicians. They try to show to audience whether this is a fact or not. Another thing I remember is in expert system configuration. There's two database, so they separate out fact DB and also rule DB when they developing a expert system. So they try to separate out fact and then the others. And then goes to second question, whether is it fact enough or not? This is a question, right? When we put a fact like this one, right? Is it a real fact or not? Somebody is questioning about this one, right? So we should have some kind of probability of fact. Right? So many people are saying on hold until we find it is wrong, right? On hold. There are so many theories and new rules are on hold until now. So if we found there's some another fact that break this rule or theory, then there will be another is coming as time and technology go on. All right.